So far this semester, we've spent a lot of time calculating currents and voltages. We understand the physical significance of current and of voltage, but there's one level of physical significance that we haven't seen so far, and that is that we can use those two quantities to calculate the amount of electrical power that a particular element is absorbing or is delivering. And as a matter of fact, it's quite easy. All you really need to do is to take the product of the voltage multiplied by the current, and that will give you the power associated with that element. This is true for any circuit element, including every circuit element that you've seen so far and every circuit element that you haven't seen. No matter where you are in your career, at what point you are in your life, power will always be the product of voltage multiplied by current. It's a very powerful thing, no pun intended, to be able to know that if you just find these two quantities, you can calculate the wattage or the horsepower associated with a particular element. So if the voltage is given in volts and the current is given in amps, then the power will be calculated in watts. It's the magic of SI units, is that if you put things into the standard units, you'll get the standard units out from the equation. So let's look at an example here in figure number 1. Here we're told that the current flowing clockwise around the entire circuit is 0.5 amps. Now, of course, yes, we're told that. It's shown here in the circuit diagram, but we could have also said, oh, 25 is in series with 5. That would give me 30 ohms. 15 volts divided by 30 ohms would give me 0.5 amps. So that would work just fine as well. We can use voltage division to calculate the voltage across each of these two resistors because, of course, they are two resistors in series with one another sharing a known voltage. So we're going to multiply 15 volts times the ratio of 25 over 30 gives us 12.5 volts. And then V2 is 15 volts times the ratio of 5 divided by 30 gives us 2.5 volts. Checking the two things we always check, do those two numbers add up to the total, 15 volts? Yes, they do. Does the larger resistor get the larger amount of the voltage? And yes, it does. We can then multiply the voltage by the current to get the amount of watts. So 6.25 watts is associated with the first resistor, and 1.25 watts is associated with the second resistor. That's really all there is to it. Well, there's one more thing, and in the next video we'll talk about how to determine the direction of power flow, whether it's going into an element or coming out of the element. But for now, that's all you need to know. So if you would, take some moments to go and solve the calculated electrical power example, and then come back and we'll talk some more.